All right, everyone, today we're going to look at systems of equations. We're going to have our first video is just going to be some of the basics, and then we'll get into the solving after that. So first thing is you need to know the definition of a system of equations. So a system of equations is a set of equations with the same variables. So you can see that we have one example here of a system. So y equals 2x plus 5 and 2x plus 6y equals 10. That is a set of equations, meaning two or more, with the same variables. The same variables happen to be x and y. If we look at our non-examples over here, we have x plus 2y equals 7. That's not a system because it's only one equation. For it to be a system, it has to be a set, so two or more. And also, this is a set. There's two equations here, but these do not have the same variable. So that is why these are not examples of a system of equations either. Solving a system means to find the solution that makes each of the equations true at the same time. You will always need to write the solutions to a system as an ordered pair. And again, ordered pairs are always parentheses and x comma y. We are going to go over three ways on how to solve systems. Solving graphically, and then substitution and elimination. These substitution and elimination, we call this the solving algebraically, meaning we're showing our work. We're solving graphically, we're going to graph and look on the graph for our answer. So, in order for us to solve graphically, which is what we're going to look at right now, when solving graphically, the solution is the intersection points of the line. So that's very key. If you look at a graph, if you see two lines intersecting, the solution to that system is where the lines are going to intersect. So if we look at example 1 here, we have y equals x. So remember, actually we'll do example 2 here. Example 2, these are in standard form. So the first thing we actually have to do is get the y by itself for each of them. So for this first one, I'm going to subtract x, and I would have negative y equals negative x plus 4, and then divide everything by negative 1. So my first equation here is going to be y equals x minus 4. So for the equation y equals x minus 4, my slope, there's a 1 in front, so 1 over 1. My y-intercept is 0, negative 4. And so we would start at 0, negative 4, and go up 1 and over 1. Up 1, right 1. And then we can also go down 1 and left 1. And you want to really fill up the graph here because we're not sure where those lines are going to intersect. So we want to make sure we get as many points as possible. For our second equation over here, I want to subtract 3x from both sides. So I'd end up with the equation y equals negative 3x, which would be a slope of negative 3 over 1 and a y-intercept of 0, 0. So here we would start at 0, 0 and go down 3 over 1, down 3 over 1, down 3, right 1, and we can also go up 3 and left 1, up 3 and left 1. And when we go ahead and graph this, again, we see that there's an intersection right there, which is where our solution is going to be. Just recall we do have to write that as an ordered pair then, and that ordered pair would be 1, comma, negative 3. So that's our solution. All right, I'd like you to try now example 1 on your own, which is a little bit easier because they're in slope-intercept form. Remember, there is really a 1 in front of this x, and then there's really a plus 0 at the end. All right, as we're going through these, remember the slope is 1 over 1 because there is really a 1 in front, and then since there's really a plus 0 at the end, our y-intercept 0, 0. And we can start at 0, 0 and go up 1, right 1, and down 1, left 1. With regard to the second equation, our slope is -3, which we can put over 1, and 0, 8 as our y-intercept. So we'd start at 0, 8 and go down 3, right 1, down 3, right 1, down 3, right 1, and connect our points. And again, that would be our solution where they intersect. And that is the point 2, 2. So bottom line, to solve graphically, we are going to graph and find where they intersect. The other part of this video is going to be talking about the 3 different types of solutions. So we are actually on page 14 now. This video is also just going to go over the 3 different types of solutions. So again, this is page 14 if you turn to page 14 in your notes. So the different types of solutions there are that lines can intersect. So that is just like the graphs we just went over. The lines intersect at one point. So we have one solution. And if we sketch a graph, we had a graph going this way, graph going that way, and they intersected at one point. How else can you graph 2 lines? Well, the lines could be parallel. And if lines are parallel, are they ever going to intersect? Absolutely not. So therefore, we have no solutions if the lines are parallel. Now, how do you know if it's no solution? Well, if you're not graphing it, let's say you're doing your work by hand, you're doing it algebraically, what it's going to look like is you are going to get both variables to cancel out. So like the x and y's will both cancel out. And the remaining statement will be false, or the remaining equation is false. So you will get something like this. 3 equals 0. 3 does not equal 0, and if you get a false statement, then you know it is no solution. The other way you can graph 2 lines if the lines are on top of each other. And if the lines are on top of each other, you would have a line, and then you'd have another one right on top of it. And if you think about how many times they're really intersecting an infinite amount of times. So how many solutions do you have? You have infinite solutions. And again, if you don't see the graph, how do you know if it's infinite solutions? Well, again, what's going to happen is both variables cancel out. But now the remaining statement is true, or the remaining equation is true. So that's the key. True statement versus a false statement. And so what you're going to end up with is something that looks like this. Maybe 5 equals 5. There's no variables, but 5 does equal 5. All right, that's the basics of systems. Watch the next lesson to learn how to solve algebraically.